Standard workflow automation relies on deterministic paths. We map out sequential steps, and the system executes them perfectly. But when business operations involve unpredictable variables or require evaluating unstructured data, rigid logic fails. Look at this standard workflow canvas. It represents a strict conditional pipeline. Explicit rules are built, and inputs travel fixed tracks to produce pre-programmed outputs. Ask that pipeline to evaluate a nuanced request, prioritize actions on the fly, or make a choice without an explicit rule, and the architecture buckles. This is why n8n introduced agents, a feature currently in preview. Instead of following fixed paths, an agent operates as an autonomous assistant, capable of reasoning through fluid, open-ended requests. Notice the Agents tab in this project dashboard. Agents exist as first-class artifacts in your ecosystem, operating natively alongside your traditional automation workflows. We will deconstruct exactly how to use n8n's component framework to transform a standard large language model into a stateful, autonomous system architect. The limitation of node-by-node execution is clear. Goal-oriented, dynamic decision-making provides the necessary upgrade for complex operations. This animated flowchart illustrates the reasoning loop. Instead of moving point A to point B, an agent operates in a continuous cycle. First, it reads core instructions and evaluates the prompt to decide its next action. Next, it autonomously triggers a connected tool, runs the execution, and analyzes the return data. If the objective is incomplete, it repeats the loop to take the next logical action. A basic language model simply generates text. An agent leverages this iterative, self-correcting cycle to take continuous action. In this settings interface, the first step is establishing the reasoning engine. You select your language model provider and input the necessary API credentials to power the backend. Moving to this prompt box, n8n provides an AI assistant. You can describe your intended operation in plain text, and it will suggest a starting template of instructions and tools. From there, we enter this main configuration hub. This is where you establish the strict operational identity of your agent. The instructions field acts as the system prompt. Here you define the agent's exact role, its tone, required output formats, and strict behavioral constraints. Broad instructions result in unpredictable behavior. You must refine these parameters with high specificity before attaching any external capabilities. Language models operate within a defined limit called a context window. Concise, exact instructions prevent the model from dropping variables or losing focus during deep, multi-step reasoning loops. The model and instructions provide intelligence, but without an interface to external systems, the agent remains completely isolated. Notice the Tools row in this interface. Tools are the discrete actions an agent can execute. These include standard built-in n8n integrations, custom actions defined by JSON schemas, and external capabilities accessed via MCP servers. The agent assesses the state of its reasoning loop and dynamically selects which tool to deploy based on instructions. Moving to the Skills section, we find a structural upgrade. Skills are packaged, reusable behaviors designed for specific tasks. A skill bundles isolated instructions together with a specific subset of tools. This prevents the agent from stalling or hallucinating when presented with too many distinct operational pathways at once. Giving an autonomous system the ability to write to live databases introduces immediate security risks.
Unchecked execution in production environments can be highly destructive. To manage this, you use the Approve Tool Calls feature. For sensitive actions, the agent's reasoning loop pauses indefinitely until a human reviews the action and clicks Approve or Reject in the chat interface. Modular tools and skills provide necessary actuation, while approval gates enforce a strict boundary for safe deployment. Workflows are typically stateless. They execute their logic and immediately discard the context. An autonomous agent requires state to function across an ongoing dialogue. By default, an agent uses session memory. This short-term mechanism maintains the context of the active, ongoing conversation without requiring any setup. In this settings panel, you can enable episodic memory. This allows the agent to recall historical context from entirely separate past sessions. Notice the requirement listed below the toggle. Episodic memory relies on an OpenAI credential to actively store and retrieve these source-backed records. Finally, this Knowledge tab allows you to connect vector stores or upload files directly on n8n Cloud. This provides external, file-based context using Retrieval Augmented Generation, or RAG, infrastructure. Layering these persistent memory systems turns a stateless text generator into a continuous, contextual operating environment. Forcing a single agent to hold instructions for vastly different multi-stage tasks degrades its performance and reasoning accuracy. The architectural solution is to use subagents. These are specialized published agents that act as modular delegates. As shown in this diagram, a master agent evaluates the user's overarching request and dispatches specific parts of the task to the appropriate specialized subagent. Looking at this numeric input in the settings, administrators can scale this architecture, configuring up to 20 subagents to run concurrently. Moving this architecture into deployment requires a strict operational boundary between the draft state and the published version. When you publish an agent, n8n takes an immutable snapshot of its current configuration. This ensures that any scheduled triggers or connected channels interacting with the live agent will not break while you actively edit the draft version. Coupling sub-agent delegation with strict version control results in a highly stable, enterprise-grade autonomous architecture. In production, a published agent waits for a trigger from a connected channel or a recurring schedule. Once triggered, it runs its reasoning loop until it arrives at a final response. Every single exchange, tool invocation, and pending approval is permanently recorded in this interface under the Sessions tab for administrative review. Engineers rely on these specific session logs to debug reasoning failures, track tool usage, and iteratively refine the system instructions over time. Continuous auditing of the session log is the definitive method for tuning the accuracy of an autonomous system. From an infrastructure standpoint, agent activity consumes your platform's execution quota. The pricing metric is straightforward. A single turn, where a user sends a message and the agent produces a final response, counts as exactly one platform execution. Because agents and workflows share this exact same execution quota, projecting the costs of scaling autonomous operations remains highly predictable. If you found this breakdown useful, please like and subscribe for more automation deep dives. Let's work together. Contact us at AMDR Automate AI or at AMDR Automate.